So let's just do an example. Let's say we have 1/3 divided by a whole number such as 2. Okay. So what that means is that we're taking a number that is less than 1, like 1/3 fraction, and we're dividing it into two parts. So we want to know um, how many parts are we gonna have if we divide this. So you can draw a diagram to show that. You can draw, for example, 1/3. So let's go ahead and do that. 1/3, and this third, you have 1/3, 1/3, 1/3. That means that each third we're gonna cut in half, such that we end up with, of the whole, we end up with 1 out of 1, 2, 3, 4, 5, 6. That means that 1/3 divided by 2 gives us 1/6. Okay, so if we share 1/3 into 2, is um each one is going to be 1/6. That's what that means. Okay, so is there an easier way to do this without doing the diagram? Yes. So what is that way? The way is that we are going to keep this fraction. We're going to do this algorithm where we're going to keep, let me write it here, keep. So we're going to keep this part. This right here, this, we're going to switch. We're going to switch to multiplication. So switch to multiplication, and this one right here, we're going to flip. This one we're going to flip right here. The second part of our expression, we're going to flip. Okay, so let me see how that works. So I'm going to do it again. So without the diagram, I'm going to do 1/3. So I'm going to switch this division sign to multiplication. And this I want to flip, because in reality this 2 is, as a fraction, is 2 over 1. So we're going to flip this as 1 over 2. Such that we can just multiply across. 1 times 1 is 1. 3 times 2 is 6. So the answer is 1/6. And this method works with any division of fractions. Okay, so also understand that every time you divide a unit fraction by a whole number, you're always going to get a number less than 1. Because you're dividing a very small number, a number less than 1, by a number that's greater than 1. So you're going to get a number that's even smaller. Okay, so how about unit whole numbers? Whole numbers divided by unit fractions. Whole numbers divided by unit fractions. So let's do 3 divided by 1/2. Okay, 3 divided by 1/2. So what that means is that you have 3 of something. That means you have 3 of something. Okay, so let's cut this up into 3. So you have 1 over here, 1 of something, another 1 over here, another 1, and another 1. So you have 3. This right here means 3 wholes, right? And each of those 3 wholes you are dividing it by 1/2. So you're cutting it in half. Okay, so each hole, I'm going to cut it in half right here. So let me use this, cut it in half, cut it in half. So here I have 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, right? So in this question, I'm asking myself, right, how many times does 1/2 fit into three holes? Well, as we can see there, 1/2 fits 1, 2, 3, 4, 5, 6. So the answer is 6. So 1/2 fits into 3 holes 6 times. 3 divided by 1/2 equals 6. So notice that when we divide a whole number by a unit fraction, the answer is always going to be greater than 1. Because we are taking a bigger number, right? That's greater than 1. And we are cutting it up into smaller parts. So when we're asking ourselves, how many parts are we going to have? So of course, we're going to have more parts. And we're asking ourselves, how many times does this number less than 1 fit into 3 holes, right? So how many times does 1/2 fit into 3? Well, as we can see, 1, 2, 3, 4, 5, 6. 6 times. Can we use our little algorithm for this? The keep, switch, flip. Keep, switch, flip. Let's try it out. Okay, so let's try it out. Keep. So we're going to do 3 divided by 1/2. Okay, so this we're going to keep. This we're going to change. We're going to switch to multiplication. And this we're going to flip. Okay, this is, by the way, this is called the reciprocal when we do that. So we're going to take the reciprocal of this. That means it's going to be 2 over 1. And now we're just going to multiply across. And this 3 holes, that just means 3 over 1, right? So now let's just multiply across. So that equals 3 times 2 is 6. 1 times 1 is 1. And 6 divided by 1, well, that's 6. So that's our answer, 6 holes. So again, you can either draw your diagram or you can use this keep, switch, flip algorithm to solve it. All right, now that knowing that, let's go back into solving a few of these word problems. Okay, so Mai has a strip of paper that is 3 feet long. She cuts it into 1/4 foot strips. How many 1/4 foot strips did Mai make? Okay, let's see. So let's draw this strip. So Mai has a strip of paper that is 3 feet long. So let's go ahead and draw this 3 feet long strip of paper. Okay. Okay. So here I have one foot over here. So one feet, another feet, and another feet. Okay, so I have 3 feet. Okay, she cuts it into a quarter, 1/4 foot strips. Okay, so that means that each feet she cut into strips that are 1/4. So let's go ahead and do that for this. So let's cut them up. Let's use another cutter to cut them up. All right, so I have to cut up each hole here into 4. 1, 2, 3, 4. All right. 1, 2, 3, 4. All right, so she cuts it up into parts that are 1/4, right? 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, 1/4. Okay, so how many 1/4 foot strips did mine make? Well, we can see it in our diagram. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we can say that my made 12. So we can say that my made 12 strips of 1/4 foot strips. Okay, so mine made 12 strips of 1/4 foot. Oh, we don't have to write strips again. Okay. So how do we do that? So we'll explain or show you reasoning with. We just showed it right here. Can we write a division equation for this to represent our answer? Yes. What do we just do? What did we just divide? Well, we just divided three wholes into fourths. Okay, so that gave us 12. And we can test this out using our algorithm of keep, switch, and flip. So if we're going to use our algorithm, it's going to look like this. 3/1. This three wholes just means 3/1. We're going to switch this to multiplication. And this, we're going to do the reciprocal. We're going to flip it. So that's going to be 4/1. 3 times 4 is 12. 1 times 1 is 1. Well, this gives us 12. Okay. So we can either draw a diagram like this and reason like this, or we can use our algorithm to figure it out. So, what if you made a mistake and you say, oh, I think it's 1/4 divided by 3. But if you do that, you're going to get 1/12. And when we get an answer to a problem, we have to reason to make sure that our answers make sense to what the problem is asking and the context of the problem. So it's asking how many 1/4 foot strips did mine make? And if you get an answer as 1/12, she made 1/12 strips of 1/4 foot strips. That doesn't make any sense. Because how are you going to make 1/12, which is less than 1/4? See, it would not make sense to the problem. So that's why we have to use reasonableness and to reason, to wonder, to think, does my answer make sense to what the problem is asking? Okay, well, I think these we already all know how to do. We can just use the algorithm that we learned. Let's just do one of them, okay? So again, we're gonna keep, switch, flip. Okay, so the first number we keep, so that's gonna turn into 6 times, we switch the sign. Now we're gonna flip this by 4. So this is over 1, right? This is over 1. Okay, so 6 by 4, we know that's 24. So that's going to be our answer. 24/1, which is still the same as 24. All right, so let's go to this one. Now, there are 4 liters of water. How many half-liter bottles of water can you fill? Okay. There are 4 liters of water. How many half-liter bottles of water can you fill? So let's go ahead and draw that out. Let's draw our 4 liters of water. So I'm going to draw a tape diagram representing 4 liters of water. So here I have 1 liter, another liter, another liter, and a liter. So I have here 1 liter of water. Here I have another liter of water. Okay, so in total, I'm gonna have 4 liters of water. So there are 4 liters of water. How many half-liter bottles of water can you fill? So that means that we gotta cut these in half. Because here we have 1, we're gonna cut it in half. All right, just another color. All right, so here we have 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, and 1/2. Okay, so how many half-liter bottles of water can you fill? Well, as we can see from the diagram, we can fill 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can fill 8 half-liter bottles of water. Okay, does this make sense now? Let's use reasonableness to see whether our answer makes sense. Okay, so there are 4 liters of water. How many half-liter bottles of water can you fill? 8. Does that make sense? Well, we can test it out. Let me see. Let's test it out also. So we have 8 half-liter bottles of water. And, right, so this 8 is going to be times 1/2 because each of them is a half-liter bottle. So let me see if that's going to give us back 4 liters of water. So 8 times 1/2 is going to be 8 halves, which equals to 4. So yeah, so 8 liters of water, 8 half-liter bottles of water is indeed 4 liters of water. So our answer does make sense to what the problem is asking us. And let's say that you made a mistake here and you think that you were supposed to, let's say that you get it 1/8 over here, 1/8 as your answer, because you think, oh, it's 1/2. I have to use 1/2 divided by 8, okay, and you do that and you get 1/8, okay. Does that answer make sense over here? Can we fill? We can fill 1/8 half-liter bottles of water. Okay, that doesn't make any sense to the concept of the problem because 1/8 is a very small number. It's less than 1. That means you're not going to fill not even 1 liter bottle of water, not even 1 half-liter bottle of water. So that's why this right here doesn't make sense. It's all wrong. So our division expression for this problem is going to be that we took 4 liters of water and we divided that by half. Okay, that's what we did. So let's say that we didn't do this diagram and you notice that you're going to do 4 divided by 1/2. Then you're going to write this 4 divided by 1/2 and you're going to show me all your work of using the keep, switch, flip algorithm. So we're going to keep this 4. We're going to switch this division sign to multiplication, and we're going to flip this. So 4 times 2 is 8. This is over 1. So 1. So 8 over 1 is the same as 8. So that's our answer, 8. All right. Let's try another problem. 4 friends split half pound of dry fruit equally. How many pounds of fruit does each friend get? Okay, so that means that 4 friends, they split 1/2 pound of dry fruit equally. So that means that that 4 is going to be, um, well, let's see. Let's see if we have to divide, um, if we have to divide, if we have to do 4 divided by 1/2, or we have to do 1/2 divided by 4. Which one of the two is it? Let's see. Okay, so we have 4 friends. They split 1/2 pound of dry fruit equally. We want to know how many pounds of fruit does each friend get. Okay, so what is being split? What is being shared? The friends or the 1/2 pound of dry fruit? Well, the answer is obvious. The 1/2 pound of dry fruit is being shared equally. Okay, so that means that this is the correct expression, and this expression cannot be it. Okay, so 1/2 divided by 4. Okay, so let's go ahead and solve for that. So using our keep, switch, flip method, that's going to be equal to 1/2 times 1/4. That's going to be 1/8. Okay, so how many pounds of fruit does each friend get? Each friend gets 1/8 pound of dry fruits. Okay, well, does that make sense? Well, they share 1/2 pound, and each friend is going to get less than half, because you're sharing something, right? It has to decrease. So that makes sense, right? So this answer makes sense. So we can be confident that this is our answer. But let's say that you made this mistake over here and you thought that this was the expression. So you say, oh, it's 4 divided by 1/2. Oh, let me see. Let's solve for that. Keep, switch, flip. So that's going to be 4 times 2. So the answer is going to be 8. So let me see how this fits into the answer here. How many pounds of fruit does each friend get? Each friend gets 8 pounds of fruit. Huh? Does that make sense? They're sharing, 4 friends split 1/2 pound of fruit equally. How is each one gonna get 8 pounds of fruit if they're sharing 1/2 pound of fruit? So that means that this doesn't make any sense. It's completely wrong. So we cannot use this. So again, when we solve a word problem, we have to assess the reasonableness of our answer to notice whether our answer makes sense to what the problem is asking.